Hey, folks. Um, we're going to do yet another edition of the Critter Stack live stream. Going to warn you up front, I'm admittedly riffing much more than I normally do. So, folks, feel very free to ask any questions, no matter what it is, and I will try to get to it. Get things going for the specification pattern. And as I get a chance, once we get past vertical slices, I'm going to show off some of the very latest test automation helpers that just got released yesterday for both Marten and Wolverine. But hey, let's start with railway programming. You'll find this mostly out of F# circles, mostly talking about composing stages of functions so that you never throw exceptions. I'll let you go find this on your own. For folks that try to do it in C#, usually end up with some kind of custom result type, a ton of generic types every which way, and it kind of turns into a lot of nested lambdas and really high ceremony. Let's look at the Wolverine approach, which I'm not sure if it counts as railway programming, but it's at least an analog and at least in the same genre of attempts. Let me switch over to some Wolverine code. All right. So using incident tracking yet again as a possible a possible problem domain. Sorry, get started. So y'all, I played a lot of high school football way back when I was much younger, and I've got a lot of scars on my knees to show for it. And I was actually a really good linebacker, but no matter what happened, the first play of the game, I always got totally blown up. Just get demolished by an offensive lineman. And once I got that out of the way, that first moment of being stunned, then I was good the rest of the game. Kind of like that for public speaking for me. Just got to get over that first fumble first. So this is a single slice for handling, categorizing an incident. And when we do this, there's a couple things we have to do. There's a little bit of validation. Now, I should say, if we cared about it, the categorized incident, yeah. So Wolverine has some built-in fluent validation middleware. Every tool like this does. What's a little bit special about Wolverine is it's smart enough to kind of look ahead through the IOC container, and it knows if you have any fluent validation validators, and if such, it's going to hard code and inline that into the generated code. It's just one of those tricks that Wolverine pulls to be just a slightly optimized over other tools. Other tools have to do a runtime probe every single request of look up the container. Do I have any validators for this command type? Nope, go on. With Wolverine, it does that if-then kind of logic up front, and there's no IOC probing at runtime. It's just a small advantage for Wolverine, but those things add up. Just kind of letting you know, working with client that's struggling a little bit with the fluent validation. Not really struggling with the fluid validation, but just I think sometimes they struggle a little bit to know where the validators are and if they exist is kind of magic behavior. I think I've been making a very strong recommendation, and I got this idea off of other people. I didn't make this up. If at all possible, I really like just putting the fluent validation validator as an inner type right inside of the command type or the message type, if you possibly can. It takes away it just removes magic. It's a little more obvious when we're looking at the slice, where does this go? And if you can't put it in the DTO, maybe make it an inner type of this, or at least put it in the same file. The point is, when you're reading the slice, it really helps if you can kind of go top to bottom and see all the stages and steps that happen in processing this command. That's the big thing. The implicitly discovered validators can be a little more problematic if if your commands and your handlers are in one project, but the fluent validation validators are somewhere totally off to the side. Basically recreating that kind of onion or clean architecture style of organizing code by technical stereotypes. That kind of always just leads you to this kind of problem. Hey, Major, thanks for joining. Then just thinking a little bit, because this has come up lately, what is good in fluent validation versus what can you do in Wolverine that's a little more explicit? I want you to look at the method that I have highlighted here. So with Wolverine endpoints or handlers, you're not limited to just having that one handle method or one post get, whatever it is. We have this concept of compound handlers, where there's a naming convention and there's also attributes to override it. We can put other methods in here that kind of be part of a stage of handling this whole command. And one thing is, if we have the validation logic that's very domain centric, or even more so requires data access, like if you have to reach into Marten to go get a related piece of data, like to say, don't put that in fluent validation. If you're using services and this is something that's specific to one slice, put this method right in here so you can still see, you can very clearly discover what are all the logics. Now, in this case, this validate method, it's going to run before the main post method, just so we know. Right here is where we're defining how do you find the incident that we're working on that's referred to by this categorized incident message. That'll be the same thing poked into this validate, but this gives us a chance to do a little bit of kind of preconditions. And why I call this railway programming, sort of, kind of, poor man's. What it does is it gives us a chance to pull the cord on all processing. So this problem details as its return. If it's no problems, Wolverine's going to keep going at runtime. If it comes out as anything other than that, it's going to write the problem details out to the HTTP response. We're going to status 400. We're going to get a little bit of information, and that's it. It stops. We don't go on. The railway programming-ish thing here is we're not having to throw any kind of exceptions to stop the alarm. We're able to kind of separate out the stage of validation from this part here, which is pretty clean. We can make the main handler be a pure function that is mostly the happy path. And my coworker didn't like that because there's somebody walking outside. Even more so, even in terms of data loading, this write aggregate, this is actually generating a little bit of middleware, injecting it into the generated code. So this is trying to read the information about the incident aggregate, maybe forwarding it based on Marten projections. Maybe it's loading it straight snapshot from the database, just depending on how Marten's configured for it. But same kind of railway thing. It's loading it for us. It'll be pushed into this as a pure function. But if it doesn't exist, Wolverine's kind of configured to, hey, I am going to return with problem details and a 400, just saying, hey, you tried to post to an endpoint about an incident that doesn't exist at all. And this would actually trip off before you get here. You can see it from the generated code. This is where the railway programming comes in. There's no point we're throwing exceptions. We're just being able to handle this by stage. The first thing, the command comes in, we run the fluent validation against it. Wolverine really is. If the version or ID is missing or 0, it's going to stop and it's going to write out the fluent validation failures to problem details. We like the problem details spec. It just makes a lot of sense. We kind of standardized on it. Not many people are complaining about it. That's the first step. The second step would be trying to load it. And if it doesn't exist, we're going to write out the 400 and get out of there. Then we're going to run the validate. The validate happens later because it's dependent upon the incident data. So Wolverine's smart enough to know, hey, this is generating the incident. This guy uses the incident So this gets sorted first. This gets sorted second. And then finally, once everything's good, all the conditions are met, you finally get to the post method. And it should, at this point, should be a happy path. The command is valid. The incident exists. This is some extra stuff that might be loaded from middleware. You know, you're referring to a valid user and go off from here. And now we've got a pure function. It's pretty easy to unit test. To Major's question, is there any big difference between using the validate method versus using Wolverine before? Not in the slightest. It's the same. It's the exact same thing. All of those are just tools for how Wolverine discovers it and says, hey, this is a method that should be run before the main handler. So this code, and now we're going to say, you can do this to make it be a more descriptive method name. And then this just tells Wolverine, hey, this should run before. So the built-in naming conventions: validate, load, validate async, load async, before async. But some people like to use more declarative, more descriptive names for the methods for obvious reasons. So do that. You just got to add that one attribute there just to tell Wolverine what to do. So no difference in functionality whatsoever, just how it's discovered. I would say it's a preference issue more than anything else. Okay. So that's railway programming. The general idea is we're going to get completely away from having any kind of exceptions thrown in our main handlers, and largely trying to remove, namby-pamby, fussy validation rules away from the main functionality. So this can be a simpler happy path. Hey, it's gotten past all the little checks. Now I can know I can just do my thing. Theory here is that this will simplify this code. It will definitely, in practice, it definitely 100% reduces the layering and reduces the arrowhead code inside of the handlers, and hopefully makes things easier to use. Downside, just a little more vertical scrolling. Some people won't like that. And of course, some people just don't like the idea that this stuff is all in the same file because 20 years of clean architecture. All right. Any questions on that before I go on? All right. So I have somehow never, even though I love Humphrey Bogart movies, I have somehow never seen this, the movie that this is from. But yeah. For the most part, I'm going to say you don't really need to use the repository pattern for your data access in Wolverine. I mean, there are always exceptions, of course. For the most part, here, I'm going to look at an example. We got a couple toys in Wolverine. Let's get to the Wolverine code. Oh, that is not the one I'm looking for. Yeah, this is a good one. Okay. So I told you another naming convention is to say load async or load. And you can just deal with this all in one place. And this is doing it with an exception. We could also throw in, it's a message handler. It's a little more helpful to throw exceptions because the error handling kicks in. I'm not worried about that. But the actual handler here, when I want to call ship order, I need to know order information and I need to know customer information to be able to decide what I need to do. There's nothing here. It's all fake. So I want to load these two things at one time. I can do that up here. It's kind of a one-off. I can load everything and having it pushed in. Now, this is a really old example. So let's use some newer, fancier stuff. inside of Wolverine. So the first trick, if people don't know about this, is the declarative data access handlers. Think about how many times in your system where you just load a single entity by its identity. And it doesn't matter if it's entity EF Core, Marten, RavenDB, we support it all the same. We're take a property off of the command message or the query message, go load that one thing. So instead, we do entity. All right, now just make this declarative. Looking at the ship order command, just know that everything that's being done through magic conventions can be done explicitly. But if I'm loading an order, it's going to try to pull that entity for that order off order ID or customer ID. Or if you're only loading one thing at a time, just use ID. All right. So by doing this, we can completely eliminate this with maybe a little more help. Doing this will kind of set us up for a little bit of railway programming. So if either the order or the customer is missing, Wolverine's going to stop processing the handler. We can throw more, except more. You got more control over how to handle what's missing, and it is more attributes. But the point is, we can make this declarative, and we can completely eliminate this guy altogether. Before we do that, I want to talk about something else. Let's pretend this doesn't exist, but we want to get the order and the customer together. If you followed me, a lot, I talk a lot about the kind of the pain and the problematic nature of systems where you make a lot of chatty calls to the database. It's really endemic to heavily layered systems where an HTTP request comes in and it calls a class, it calls a service, it calls another service, and they're all fanning out. They're all doing data access. And you end up with a spot where you could be making hundreds of different database calls to fulfill one web request, and you can't tell because it's just all scattered around everywhere, right? Those repository, those really thinly wrapped tight repository pattern things where you get the load async on the repository, those are terrible for this at all. So just taking this a simple example, we want to make it such that we want to remove that network round tripping, and we want to batch up queries to the database. We're using Marten here, makes this a little easier. So let's make sure I remember how to do this. Boom, boom, boom. Okay, we're going to create a query batch. I'm going to say give me just a little bit. And do notice that this is a little bit of annoying kind of repetitive code. We're going to talk about that in a second. Okay, and now I can say order is and I can say customer is okay. So this is an equivalent bit of code to what I had before, except now I'm using Marten's batch loading. So this is going to get the information for both customer and order all at one time, one round trip, as opposed to one round trip, second round trip. Reducing network round trips to the database, it's one of the single best things you can do to make your system faster, or really just to keep your system from becoming grotesquely slow as the code bloats and the system grows over time. So the point is, this is super important to do this. Couple more things. points I want to make out of this. The Wolverine ideal here is we're going to ditch the repository abstractions most of the time. One of the reasons to do that is those thinly wrapped iRepository type abstractions, they hide so much of the power of whatever your infrastructure tool is. In terms of Marten, you lose the batch querying, which is super important. You lose Marten's ability to do includes between related entities. In EF Core, you lose a lot of control, fine-grained control over lazy and eager loading. Same thing for our RavenDB support. But by embedding, saying that any bit of data access that is specific to a single slice, just embed it here as a load async. You can still keep it out of the main handler, so your business logic is pure. But if it's only being used in one place, do it right in a slice and use every last bit of power that your persistence tooling happens to have so you can have a better system. All right, I'm gonna come back down here. So with this load async, this is loading it by itself. So if you were using that pattern, this is unnecessary. This actually creates more work. But this is really simple. This is much simpler code than this. Just throwing these attributes, I'm going to argue, is much simpler code than going through the batch querying stuff. But also, let's just kill this now. So the super cool part about this, if you're using Marten with Wolverine and you're on Wolverine 5.0, this does not exist in 4, this is new in 5. When Wolverine sees, hey, you're loading multiple entities or multiple aggregate streams, just more than one thing that would go to Marten that I know how to batch up, Wolverine's actually generating batch query code around this, and you'll see it in the generated code. It's a lot more code noise. It's code you don't necessarily want to write yourself, but it's a pretty significantly important performance optimization that Wolverine can now do behind the scenes for you. This also does include, if you're doing the aggregate handler workflow with multiple, let me look at my notes. If you're using aggregate handler workflow and you're trying to work on multiple streams at one time, if you're still using the write aggregate or read aggregate entity attributes to declare this is the data I want, Wolverine's able to batch that up to Marten as well. And that one's a killer. All right, let me catch up with questions. Taylor. Started with fast endpoints but EF, but orchestrating multi-step workflows. Should core entities like order live in EF core, but Saga stayed in Marten, or should everything be in Marten? Think about it slice by slice. So Wolverine does support Saga storage with EF core, which, it's more work than it is with Marten, because Marten's just easier than EF core. But if your Saga, as it's handling Saga events, messages to a Saga, if it is also making calls through an EF core DB context, you could be more efficient in Wolverine by using EF core at the same time. That way, persisting the Saga and any outbox messages and whatever changes you're writing inside the Saga method itself, that can all happen in the same database transaction, which is, really good for consistency. But again, that's also a way of helping you reduce network round trips. That's actually a question that came up on Discord the other day. I don't know if that was you, but that question's come up before. If you are using Marten and you're doing multi-step workflows, I would strongly consider skipping Sagas altogether and just use Marten event streams plus the Marten projections for the current state as really an equivalent way of doing Sagas. I think that the aggregate handler workflow is just a tiny bit cleaner than the Saga stuff. Not that the Sagas are high ceremony, And then having the events kind of telling you what and when steps happen in the multi-step process. I think that's super handy when it comes time to troubleshoot in real production. What's happening here? When did it happen? So that's something to handle. I mean, there's automatic tracing and logging every which way around the sagas. You have open telemetry around it as well, but it's just super handy to be able to look at the event stream in the database to know, order shipped at this, order was created at this time by this person, and it shipped then. So just think about that. And then, hey, Jeffrey, good to see you, man. Okay. We talked about it, declarative testing. I'm going to get into integration testing in the next section. So kind of closing out the vertical slice stuff. Really just a leftover. Just a few. It's not all of this is really particular to Wolverine, but it's things that I thought people would ask about. And this was originally a conference talk. So let's just kind of take these one by one. So some people, when they talk about code reuse between slices, is it okay to reuse code between slices or should you not? As probably all recall from the very early days of microservices, there were some people that took that very extreme approach that, you should never share you should share nothing between microservices. So they're completely independent. They can always be developed independently. I always thought that was going too far. I mean, yes, coupling between services on shared utility libraries can frequently be problematic. But sometimes the duplication is worse. With slices, I think individual slices are, hate to go down the DDD rabbit hole stuff because that stuff's so too vague. But I mean, there's multiple slices inside of the same bounded context. I think it's silly to take an extreme down to not sharing code between slices. I guess I might come back to data access just a little bit. I just wanted to point this out. We're talking strictly about code reuse between slices. I had talked in Marten that the Marten Wolverine combination, but you can do the same thing with the core. For the most part, if data access is specific to a single slice, I want that data access just right there in the slice. Right. I need to understand how it impacts the message handler, query handler, whatever it is. It's just the way I want it. I don't want it all scattered in a repository in a separate project 5 layers away. If you do happen to have some queries that are shared between slices, like querying for all the open issues between a certain time, there's an idea called the specification pattern. It's just a way to kind of creating a stored procedure for your data access. Here is a reusable query. I can throw different parameters at it, but I only have to code the logic once and I kind of reuse it. So flipping into Marten, let's see if I can find a good example. Marten actually has 2 different implementations of the hey, that was written by Corey way back when. That's awesome. I mean, this is pretty fake. 2 concepts of the specification. So the first one, the older one, it's less powerful but faster. It's the idea of a compiled query. So you can kind of create a stored procedure of sorts for a link query. And then we can start to query this. Let's see how it's used. So I can query in Marten by just passing in the compiled query object. Like here's a query I want you to, kind of a pre-canned query I want you to use. To go back to the idea of vertical slices, I'm perfectly cool with reusing these across slices if they come up. These even play nicely with Marten batch querying. We don't have anything magical in Wolverine to make that easy to use yet, but we'll get there. Cool thing about compiled queries, looking at your link stuff, this one's really simple, but some link queries, there's actually a non-trivial cost to being able to reach in and parse and interpret your link queries. I mean, the link internals are pretty nasty. It's not running your code. Remember, it is parsing that code. It's going through an expression tree. It's trying to figure out, how do I map this to a SQL statement? And then when I execute the SQL statement, how do I read the results? And it's super involved. What the compiled query does is it kind of creates a plan, a kind of a pre-built plan of, this is the exact SQL you'll use. Here's how do you push parameters in. Here's the exact little strategy that knows how to read it and coerce the raw database information to exactly what the user wants. This is a little performance optimization that I don't deal with many people having problems with this, so that tells me people don't use it anymore. But it is potentially a way of getting a little bit more performance out of your system. So that's one idea. The other idea, this is much newer. And this is built in mind for a JasperFX client who had, one of those, struggled a little bit with one of those crazy clean architecture ideas, where they had a ton of layering. So the idea here is, we have a new version of specification for Wolverine, or for Marten. It's about 6 months old, maybe a year old, called Query Plan. And in this one, you can do any possible thing you want. And you could reuse these Query Plan objects at will in your own code. Show an example. It's not that different, but what is different is this. It's not pre-compiling the link or anything like magic like that, but it allows you to do any possible thing you can do with a Marten document session, you can do with this. So that gives you a way to reuse query logic between slices without duplicating the actual code. Just thinking, this is one of those places where you find out a query is wrong, maybe the where is wrong, the ordering is wrong. You can fix it in one place, because sometimes duplication is really a problem. Hey, so Binary Lizard from South Africa. Man, that's a long ways away. Welcome aboard. So that's the specification pattern, and all that really ties back to code reuse between slices. I just tie that back into the data access. You have a way of reusing data access logic without doing something bonkers like pulling off more shared repository stuff. Because Wolverine wants you to have a slim call stack. It wants you to have fewer layers, fewer IOC registrations, and all that jazz. This is the part where I'm going to get in trouble. So, everybody always wants to talk about, how do you name your files? How do you organize your files? How do you split them up? And I have some soft opinions, but not really. My take is that modern IDEs, like I use JetBrains Writer or Visual Studio.net, it's just really easy to move files around, even move types around, let it correct. The IDE will correct your namespaces for you. And because it's reversible, it's just easy to change your mind. Don't sweat so much about it up front until you kind of see how your system's growing and how you might want to break it up. That being said, where it works, my personal preference is if a slice is small, put it in everything in one file and name it after the command. The command or the query. And when you do that, so this file I'm showing here is just called categorize incident. That's the command type. And personally, see, I'm good with omitting the technical stereotype suffixes. Anything that's still remnants of Hungarian notation. Just there is a very common idiom in our industry with CQRS that command objects are, named as some kind of imperative, do something, where events would be, something in the past tense. So it would say something was done. I think that idiom is so common that I would ditch the command suffix here. Just yet another way of just reducing code noise and character noise. So when I'm looking at the system and I want to understand its capabilities, if I can look at the files, and the files or the folders represent the logical transactions and operations in the system, that kind of, people call it the screaming architecture. It helps you understand what the system does much faster than you can if you get one of those, layered systems where there's incident controller with a million things and incident repository and whatnot. Okay. Now, some things, if it's a really big slice, where the stuff is, the code's getting too bloated, sure, go to a folder and split things up. I do that myself. I do that on by feel. This is a big one. One of the biggest reasons to do vertical slices in the first place, but also in my experience, one of the things that is most where you get the most pushback and controversy from people that hearing this first time. Should you be standardized across slices? Should you have the exact same layering philosophy between slices? One side, people like the uniformity and consistency inside of a code base. You could drop somebody into a code base and they kind of know how it's put together. I get that. I hate that personally, because I think what happens if you try to standardize on this is the exact layering approach. You should always have a controller, a service layer, a repository, DTOs, whatnot. I think you end up with one of two extremes pretty frequently. Either you end up with a lot of tiny methods that just do a straight delegation that don't really have any reason to exist other than they follow the template, or the use case in question is way bigger than the template allows for, and you get those bloated controller methods, you get bloated service methods, bloated everything, and it's still really hard to work for. I really like the idea of letting it vary on slice by slice. Maybe you just limit it to a couple of, these are the approved patterns. Here's if you're a technical leadership, you're trying to explain how should people do things. Here is the decision tree of, if it's like this, use pattern A. If it's like that, use pattern B. If you don't think any of this fits, let's have a conversation. Right. So using a sports analogy, the people that want to standardize things, when you're talking about prospective players coming into a sports league, you talk about sometimes, oh, this player has a high floor, but maybe a low ceiling, meaning you have a reasonably good idea that they're gonna be this good already, pretty safe bet. Or you might say somebody has a high ceiling, meaning they have untapped potential. So I think the people who are really worried about standardization, they're taking the philosophy that they want to raise the floor. This is the minimum level of goodness in our code base we're going to get to. People that aren't so wild about standardization, that want I want slices to vary in their approach based on the particulars of the use case. They're trying to raise the ceiling of how good things would be at the cost of, yes, developers need to be thinking more as they work, but also I really think it's a good idea for developers to think as they work. Jeffrey's asking, any thoughts? When would you consider moving a slice into a headless service? Man, I think if it's so big that, Jeffrey, I think of a slice as a single handling a single message or query handler or a single HTTP endpoint. If that's really so big that you feel like, if it's really, really big by itself, and it's possible, if it's disconnected from everything else, that's maybe when you consider moving into a separate slice. But it would all be, I think my thinking would all be around kind of the rate of change. Um, does this slice change a lot, and do those changes isolated into only this slice? If that's the case, that may be something that you could pull out and move out. But if it's something where, hey, anytime I have to change the code in this slice, I almost always have to change code over here. That means it's the same logical bounded context, and no, you don't split those out. I don't know if that's helpful. Um, what people are going to ask, what if you want to swap out databases or other infrastructure? Because that's part of the purported qualities of clean and onion, really ports and adapters, having abstractions for all your infrastructure. Theoretically, you can swap them out. I don't think the clean onion thing actually works. I don't think you're actually able to swap out databases or infrastructure because your system is just too damn big and it's just too big of a project. I think the vertical slice thing can help if you can if you get into a world where like you could upgrade Marten versions for one module or EF core versions for one module within the system, that helps. I think the single best thing you can ever possibly do to make it easier to swap out databases or other infrastructure is just having very, very effective test automation coverage. Jeffrey says the issue is how long the test takes to do a deploy. They have some hotspots that they want to deploy frequently. If it's something that's changing independently a lot, I think that's your heuristic. If it's changing a lot, a slice is changing a lot, the rest of the system is not necessarily, and those changes are really independent, yeah, that's when I would very seriously consider popping that out to its own service so they could have its own release cycle cadence. I mean, that was the original goal of microservices before everybody got disillusioned. All right, so I think I wanted to just kind of put a bow on the vertical slice thing. The single biggest thing, if this is me talking, this isn't generally accepted wisdom anywhere else, but I want to keep related code closely together. So, looking at a vertical slice where we had data access in one method and the business logic behavior in the second, I mean, you still got separation of concerns, but that very closely related code is all together where you can reason about it a little more easily by just following step one, step two. Here is, I can look at the business logic function by itself, but when I need to, I can see how does this interact with the database and down? How does it send other messages? Because all that's important. I'm going to say, yes, you even want to put the data access code as close to the business code that is related to it. Again, it's your ability to reason about it. It's your ability to understand that, hey, we're making umpteen million database queries for this business logic when we could be making one call, or we're querying for the same information over and over again, which is a pretty good pattern in onion clean architecture systems that have gotten out of control. I really like that A-frame idea for separation of concerns. For people that are coming from a functional programming perspective, this is the imperative shell functional core idea. But the general idea is keep your business logic, anything's workflow logic, anything that's deciding what to do, keep that in pure functions that are easy to read. And then the uglier stuff around it, have kind of like a protective layering around it that go get data from the database, push it into the pure function, and then take the results and go apply the side effects. I like the A-frame architecture expression of this approach, but if you're a functional programming person, you're going to like the imperative shell functional core idea. Basically the same idea, just getting there from different verbiage. As slices, closely related slices, keep them together. I think that fits well with the DDD bounded context idea. And then I don't really have any more specific rules after than that. Y'all would hate this working with me maybe, but I say for code organization, it's kind of a play it by ear because it's easy to move things around later. And then hopefully, I'm actually dubious about the modular monolith idea, but I think doing the vertical slices will make it easier to break up modular monolith and kind of pull out outposts into separate services later. We'll see. Let's come back in 10 years and see how that's actually working out. Right. So before I switch to integration testing improvements, guys, throw any questions in the chat while I get to the next code sample, if you want to. All right. So just the last couple of days, pushed a bunch of improvements for the test automation support in Wolverine and Marten both. Already applying it at a client today, and the answer seems to be it has definitely gotten better, but there's still some race conditions. But hey, let's not harsh my mellow. Let's show off the new improvements, and I'll worry about that client doing crazy stuff. First thing is being able to stub handlers. So let's say you have a system where you are publishing a mess, you're doing request reply to an external system with Wolverine. So in this case, I'm going to issue like an estimate delivery message to a totally different system that knows how to estimate deliveries. And the way I'm going to use that, so in a handler, I am, as part of it, I'm going to do a remote request reply. This invoke async, since estimate delivery, that's not handled internally. It's routed through RabbitMQ. So it's going to send that message to RabbitMQ, and it's going to wait until the recipient sends back a delivery information response back. And I'm going to put it together and I'm going to use it. The request reply. For as much as I like to brag that the Critter Stack is the best at test automation of all these tools, a feature that Mass Transit had, we didn't, was the ability to stub these kind of request reply handlers out. A couple people have asked for it lately, so now we have it. Let me see. Let me find the code. Yeah. So in a test code now, let's say you already have you have an iHost or an iService provider. And I should say the way that I like to work and the way I mostly recommend is you do most of your integration testing by bootstrapping the application into an iHost in memory. Maybe you override a few things, but for the most part, you're using the application as it's really configured. Make this point because people that set up the application differently or set up an IOC container a little bit separately, you can kind of get false negatives, false positives in your testing because you're configured weird and different than the real application. So that's why I'm starting from an iHost. But starting from this iHost, I can say I'm going to temporarily register a stub handler for estimate delivery, and I'm going to stub out its behavior, kind of hard code it. You can do something fancier, but anytime you call estimate delivery, I'm going to return this data. At the same time, it is also changing the internal routing of the system to know, hey, I send estimate delivery to myself instead of trying to call it through RabbitMQ. The end result is when we call our command handler that is trying to do request reply to this external system, it's going to run and it's going to hit the stub instead. So this is going to be great for having more predictable, more isolated tests, or to be able to test your own application, how it responds to the data it expects from something else. before you try to connect it up to something else. This one's actually fully documented. You can clear out the stubs and revert back to normal behavior. You can apply all new stub behavior. You can do fancier stub behavior that'll send multiple messages, whatever you need to do. But the point is, you can use this to fake out external systems that you're interacting with, you're normally interacting with. So you can have more isolated tests around one service at a time. Let me dive off major, talking about setting up a schema or test or collection. That's probably a topic all by itself. One thing I will say, again, why the critter stack is easier for testing. By default, if you're running through Marten, you can turn this off, but in default modes, Marten's going to build its database out as it needs to. If you try to save a new document it doesn't know about, it's going to go build the storage for it, and just let you work. Same thing, Wolverine can do the same thing for its inbox outbox tables, but it can also set up RabbitMQ for itself based on what you've told it the configuration is, or Azure Service Bus, or AWS, SQS, Kafka, Pulsar, basically everything you can use to do messaging with. Wolverine just sets this up. So that's this whole idea of how fast can you start from a clean clone and be running tests. Major, I know that's mostly punning on your question, but in testing, I would mostly rely on Wolverine's own ability and Marten's own ability to do that. Now, if you're talking about using a schema per test, yeah, that doesn't fly for Marten. You can try to do things with test containers and use an all new database per test, and Marten will happily set it up for you on the fly. Your problem is that's potentially slow. So that's worth a discussion all by itself. We get to a few more things, but this is the message stubbing. This is documented. I know this is going to be helpful for a couple different people who've asked for this. And we're selfish. When multiple JasperFX clients say that something would be helpful for them, I have a tend to jump on it. I do pay attention to the rest of the community too. It's just clients get first dibs. Back over in the Marten stage. Let me show a scenario. So scenario I'm helping a client kind of fight with today. It's not quite perfect, but a whole lot better than it was. Let's say you have an upstream system, and part of its operations, it is persisting some events. Then the async daemon is constantly polling for events coming in, and part of its subscriptions or projections, it's actually publishing messages back out to Wolverine, which is going to kick these on to RabbitMQ. It's eventually going to land in a downstream service where the downstream service's own set of Wolverine handlers are going to eventually write some data to its own database. And we want a consistent test that hits all of this all at once without any race conditions, even though every single thing is happening asynchronously in different hosts. Good times. So first, let's talk about Wolverine. Talk about Marten. Hopefully you've seen this before, but let me come into Wolverine tests. Okay. So Marten has had an ability to just make a simple call and say, I want you to wait. I want to wait until the daemon has caught up. So if there's already asynchronous behavior, at the time that you call, wait for non-stale events. Here, I want to wait until all the asynchronously running projections and subscriptions have reached the highest event store point that we knew about when we first called this. So this has been introduced in the last year to help test automation. It's been really hard. People have found lots of it's had a pleasant shakedown cruise. I think it's in pretty good shape now. It's not perfect, and it could potentially be a little bit slower. So we have this. The one thing we have done in this last release and very recent releases is we're adding a lot more contextual information. If this times out, it's now giving you a table, a textual table, and the exception of, hey, here are all the projections. Here's the high water mark. Here are all the projections and subscriptions that should be running. Here's how far they got. This latest result is finally smart enough to put in, hey, this one didn't even start. You'll see a 0 if for whatever reason it didn't start. We've also dug into observers internally so that, all this asynchronous stuff happening in the daemon, if it's throwing exceptions, maybe sorry folks, sometimes there's actually problems in your own code in those projections, subscriptions. Maybe there's a serialization error. Maybe you hit a transient database error of some kind. But instead of those exceptions going off into the ether in tests, they are all logged in production. But in the tests, we're able to kind of capture the exceptions, and now it will come out if this times out, it will show you, it will also list off and print out the stack traces for all the exceptions that were encountered by any of that asynchronous behavior. It's a lot of words. The takeaway here is we've tried really hard so that this thing can give you a lot more contextual information about why it timed out or failed, so you have some chance of being able to troubleshoot this in the future. So that's an existing functionality. Then next one, this is built into, there's a helper inside of the track session. It's a set of extension methods that come with Wolverine Marten for using things at the same time. Let me dive into this because this is it's more about Marten. So API here, force all Marten daemon activity to catch up right now. This is a little slightly different mode of the daemon. What this is going to do is it's going to first pause all the daemon activity, and then one by one, for every subscription projection, it is run all the events from catch up to the latest point right here and now. Do everything in line. There's no polling. There's no producer consumer channels type stuff that happens normally. It's just we're going to do this all in line, so it's a little more predictable. We're going to do it fast and do it right now. Don't do this in production, but for small data sets and testing, for test automation, we're hoping that this is much faster than the wait for, because this is doing things much more predictably. So in the tests, you can embed this into the track session to get it done faster. And even more valuably, what it's doing is it's running this, but it's also kind of restarting the track session tracking. So once this is complete and it's publishing messages, we're getting into the same kind of like a second stage of track session. So it's able to look and watch the Wolverine messages that are kicking out through side effects or subscriptions at the same time. And it can try to wait until everything is handled in the downstream service. Ton of your challenge of these kind of asynchronous heavy things, we're doing arrange, act, assert. If your act, it has a ton of asynchronous behavior. It's knowing when is the act phase really done? When is this part really done? So I can move on to asserts. If you've ever had blinking tests from a lot of asynchronous testing where you have a bunch of wait fors and timeouts, we're trying to solve that problem for these bigger issues all at once. Still a little bit of a work in progress. I think there's going to be some fine tuning, but it's already showing evidence of improvement. It's just not perfect yet. And I should also say what this client is doing is probably far more complicated than you are in your system. So don't be afraid to try to tackle this stuff and use it. So that's a bunch of all new stuff. I'm kind of excited. I'm hoping this is going to be another huge wave of improvements for the Critter stack. I think those request reply handlers will be a big win for people that want to isolate their systems in more integration tests. And I guess, anyway, I'm very happy with how this turned out. I'm hopeful this is going to be a big win for all of us. And lastly, that is the end of what I thought I would talk about today. I mean, absolutely thank you all for coming. I think these live streams have been mostly positive, like the feedback. And with that, I am just open for any questions or anything anyone else wants to discuss. And I'm also going to breathe a minute. Thanks, Jeffrey. Give it just a couple more core minutes. And of course, if anybody's watching this much later, I built this slide deck pretty soon, right before Halloween, so you get David S. Pumpkins. All right, folks. You absolutely know where to find me on Discord. Some days I'm a little more receptive to questions than others, but use a Critter Stack Discord service, comments on YouTube, and thank you all for joining up. And I will probably be linking to this for the especially for the integration testing. Y'all, thank you.